Today we're going to go over the properties of exponents. This is the first part of R3. We're going to do the second part of R3 tomorrow, which will be multiplying polynomials. And then Wednesday will be a work day, and then Thursday will be your quiz. Of this week. Yep, we'll have a quiz Thursday, and your homework from Schoology is due on Thursday at 10 a.m. It'll be made available tomorrow. Okay, so what we're going to do is go through the properties of exponents. So I'll do the property, and we'll do a little example, and then the rest of the time we're just going to work through examples. Okay, our first rule is the product property. So when you multiply common bases, then you add the exponents. So x squared times x to the fourth will be x to the 6. 2 plus 4 is 6. Good. Okay, we have power to power property. So if you have an exponent inside and outside parentheses, then you're multiplying your exponents. So x squared to the fourth power will be x to the 8th. This is still power to power. But this time we have 2 bases inside. So this is when we have multiple bases. You're still multiplying your exponents, but you have to distribute it to each base. So you'll do m times p and then n times p. This isn't so difficult to see when you have bases that are variables, but sometimes you have a number as a base, and that can be forgotten. So 2 is a separate base from x. So this 2 on the outside has to be distributed to the 2 and the x. What's the exponent here on 2 that you don't see? 1. Okay, so you're doing 1 times 2, so that's 2 squared. And then you're doing 3 times 2, so that's x to the 6th. If you have a number as a base and an exponent that's 5 or less, go ahead and evaluate that. So give me the number that is. So 2 squared is 4. So I simplify that to 4. X to the 6th. And now we're going to do the quotient property. This time when we divide a common base, we subtract exponents. So you know if you multiply a common base, you add exponents. So if you divide a common base, you subtract exponents. You're always going to subtract top minus bottom. Okay, so you always go top minus bottom. Even if it gives you a negative, you always start at the top. So x to the 10th over x to the 7th would be x cubed. Good. 10 minus 7 is 3. So now we're going to do quotient to a power. So still kind of power to power, but this time with a fraction. So you still have to distribute that exponent to each base that's on the inside. Keep your a in the numerator and the b in the denominator. So that doesn't change. You just distribute it to each base. So distribute the 2. So it goes to the 3 and the x. So that's 3 squared over x to the 8th. You can go ahead and evaluate 3 squared. So 9 over x to the 8th. Okay, negative exponents. So if you have a negative exponent, that means you have to move your base. So this b is in the numerator because there's not a fraction. So you have to move it to the denominator, and you have a 1 on top. And then your exponent becomes positive. Okay? So same thing. This time my negative is in the denominator. So I have to move the base, and it's in the denominator, so it moves to the numerator, and your exponent becomes positive. So if you move it to the numerator, technically then the denominator has a 1 on bottom. But when we have a 1 in the denominator, we don't have to put that. So I see I have a negative exponent, so I'm going to have to move the base. What is the base? X, not 3. 3 is separate from x. So the only part that moves is the x. This 3 stays put, so the 3 will stay on top. Once you move it, the exponent becomes positive. Okay, so you still distribute. That's what I would do first. So you have negative NP over negative NP, because now it's a negative number. And when they're negative, they have to move. So the A moves to the bottom and the B moves to the top. And the exponents change to positive. Oh, sorry, that's A. Sorry about that. Okay, so the B moves to the top. And the A moves to the bottom. That's x squared over y to the negative 3 all to the negative 4. So what I do is distribute first, and then if there's negatives, then you move. Okay, I didn't move the negative exponents at the end, just because sometimes you'll end up with positives. So that's x to the negative 8.
Hi, Cecil. Could you please have Jacob Smith come to the counseling office for just a moment, please?
Yes.
Thank you.
Y to the 12th, because negative 3 times negative 4 is positive 12. So what is the negative exponent? Just the x. So I'm going to move that. Am I going to move y? No. So I have x to the 8th, y to the 12th on the bottom. I can't leave any numerator empty though, so I have to put 1. Good. Then our last rule is 0 exponents. So anything to the 0 power is 1. So this whole thing is to the 0 power. So the whole thing is 1. What do you get here? 2x. So y to the 0 is 1. So 2x times 1 is 2x. So if it's a variable to 0 power, you can think of it like it cancels. because that's just times 1. Questions about that? Okay, so now we're just going to work through some examples. Some of you might not do these in the exact order that I'm going to do them, and as long as you're still arriving at the answer, that's okay. Sometimes you can do these in different orders. Okay, so I see I have a common base that I'm multiplying. All right, so d squared times d to the 4th will be d to the 6th, okay, times. Here I have to multiply, so c to the 10. Here I have to multiply c to the. Do I have any common bases? Yeah, the c's are common, so I have d to the 6th, c to the 16th. Add. Any common bases left? Any negative exponents? Okay. You can put a dot here if you want, but variables next to each other imply multiplication. So you don't have to have the dot in between. How many bases are there on the inside? There are 3 bases. You have B, 3, and A. So distribute to all 3 bases. Keep them in the numerator and denominator, wherever they started. So B to the 3rd, 3 to the 3rd, A to the 3rd. Do you have any common bases? No. Any negative exponents? No, so you're basically done, except take care of your regular numbers. 3 to the 3rd, you can go ahead and evaluate that. Three to the 3rd is 27. So in R2 on Friday, we talked about how you can have variables to the side or in the numerator. So that's the same thing when there's the side, they're in the numerator. So what I'm going to do is I'm just going to put them in the numerator and look at the 2/3 as separate parts than just the 2/3. Okay, so in this first set of parentheses, I have an exponent outside, so I have to distribute that. I have to distribute the 2. So 3 bases on top and 1 base on bottom. Yeah. Correct. Correct. You can look at it as 2/3, but you have to keep it in parentheses when you do that to make sure the 2 goes to the 2 and the 3. So I think it's just easier to, from the beginning, look at it as 2m squared n over 3. Okay, so 2 squared m to the 4th n squared and 3 squared, okay, times. There's not an exponent outside of parentheses here, so these parentheses are just telling me to do what operation? Multiply. So I have 1mn squared over 2. Okay. When you have regular numbers, you do the regular operation. So 2 squared is 4. When you have fractions, multiply across the top, multiply across the bottom. So I have 4 times 1. Those are regular numbers, so I'm doing the regular operation. 4 times 1 is 4. Now I have a common base of m. So m to the 4th times m to the 1st. I have common base, and I'm multiplying. I use the exponent operation on the exponents. So 4 and 1, what do I do with those? Add. So m to the 5th. Over n squared times n squared is n to the 4th over 3 squared times 2, 18. Do you have any common bases? Any common bases left? No. No negative exponents, right? So the last thing is to take care of my regular numbers. So 4 over 18 can reduce. So keep that as a reduced fraction. Don't give me a decimal, but reduce this. So 4 over 18 reduces to 2 over 9. Your calculator can do that for you. Just use like your fraction button. Any questions about that? Okay, again, you might have done this in a little bit different order. You might have taken care of all your regular numbers first. That's fine as long as you still ended up with the same answer. Okay. Okay, I don't have any parentheses. I don't have any common bases. Do I have any negative exponents? Yes, which one has a negative exponent? The m. So this moves. What do I do with my 3? Keep it. Leave it there. So 3m, this becomes positive 2. And I don't have anything left in my denominator. So it's just a 1. But remember, if it's a denominator of 1, you don't have to keep it in your answer. Numerators of 1 have to stay there. Denominators of 1 do not. Okay? I like to remove the parentheses first, and in this case, that's what we have to do. Sometimes you'll have common bases inside parentheses, but I like to do the parentheses first, no matter what. Okay, so lots of bases to distribute here. We know we're doing 4 to the 3rd power, not 4 times 3. Sometimes people make that mistake. This is a regular number, so you do the regular operation, 4 to the 3rd power. Also, you can think of it, there's a 1 here, so 1 times 3 is 3, 4 to the 3rd power. If you want to go ahead and type that in so you have that done, that's helpful. So it's 64. You can write 4 to the 3rd, that's fine. Okay, 64p to the 9th over 3 to the 3rd, x to the 6th, y to the 3rd. Okay, do I have common bases? Do I have negative exponents? Does my number reduce? No, this is done. Okay, on this one, some of you, again, you might want to do something with your, reduce your 18 over negative 8 first. You can do that. I always wait to do those till the end. I want to get rid of my parentheses. That's what I want to do first. So I have to distribute the 3 to the 3 and the n. Three to the 3rd, 27. And then I get n to the negative 6. Do I have any common bases? The n's, right? So if you have a common base that you're dividing, what do you do with your exponents? Subtract, put it in the numerator. So this is why I wait to mess with the negatives till later. Negative 3 minus negative 6 is positive 3. So it ends up being positive and you don't have to move it anyway. And then I have negative 8 over 27. So that's 18n cubed over negative 216. So does 18 over negative 216 reduce? Yeah, it does. And you knew it would because these reduce. So therefore, these are going to have to reduce. What does it reduce to? 1 over 12. So you can write the 1 on top, but you don't, oh, sorry. But you do not have to write the 1 with that n. Questions about that? Okay. We have these 2 examples and then we're done. Okay, so this one we have to be careful because we're not multiplying a common base, we're adding a common base. So if you add or subtract, then these are separate terms. Okay, so I can't do anything with them yet as far as combining. All I can do is take care of each term one at a time. So 2 to the negative 2 would be 1 over 2 squared. Plus, what's 2 to the negative 1? 1 over 2, 1/2. What's 2 to the 0? 1. 1 over 2 squared is 1/4. So these are real numbers. You can add them and get an answer. They're in fraction form, so leave your answer in fraction form. 1/4 plus 1/2 plus 1 is 7/4. However, if these were x's, so if I had x to the negative 2 plus x to the negative 1 plus x to the 0, that's 1 over x squared plus 1 over x plus 1. I cannot combine those because they're not like terms. So I would be done here. I can't do anything with those. Okay? Okay, let's look at this last one. We're fine on time. It's 11:08. This is a little fast. So we have time to finish this one up. Okay, I'm going to distribute first. Two squared is 4. I'm going to go ahead and write 4. I'm going to talk through this one a little fast just to make sure we get it finished. X to the 6th, y to the negative 8, z squared over 18. I'm just copying the bottom down, except I don't even need to write that z to the 0. Z to the 0 is 1, so I'm not even going to write it. Okay, I'm going to combine my common bases. So I have x's and y's. I'm going to go ahead and write negative 12 on top now. So I kind of am working with my regular numbers throughout. 6 minus negative 2 is positive 8. Negative 8 minus 1. Negative 8 minus 1 is negative 9. So first thing I do is subtract, and I put them in the numerator. I'll move the negative at the end. So the only thing left in the bottom right now is my 18. Okay, I see I have a negative exponent. So I'm moving that to the denominator. Once I move it, the exponent's positive. So I took care of all the bases with exponents. Now I got to reduce my regular numbers. So negative 2 over 3. And that's set. Hold on, don't back up yet. So when I have negative numbers, that doesn't mean I move them. Okay, negative numbers are just regular negative numbers. Negative exponents are the ones that move. Okay, that's it.